right, so we're going to finish up solving oblique triangles looking at law of cosines. But first, does anybody remember what types of problems we can use law of sines for? Or maybe how many types were there? Yep, there were 3. Does anybody remember the 3 for law of sines? Brian?
I believe there was SSA and was, I'm trying to think, is it ASA was one? Or,
Yep.
And then SAA.
And then SAA. Okay, so those were the 3 types that we solved. And by looking at the table, you had to have a row that was complete. Well, law of cosines is going to allow us to find or solve 2 additional types of triangles. Does anybody remember what I said the 2 other types were? Yep, so we got side, 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 and side, angle, side. Okay, so those are the 2 new types that we can solve. Okay, so the first one, that's an example of side, angle, side. So you're still being given 2 sides and an angle, but it's very different when the angle is between the 2 sides. And side, side, side. Okay, either one of these isn't going to work with law of sines, because if you tried to set up your table, okay, in the bottom one you would know A, B, and C. Would you have a row that's complete if you know all the sides? No. So if these are your 6 things, and you knew side, 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 you're not going to be able to find a row that's complete. And if you had side, angle, side, it could look something like this. Okay, you know 2 sides and you know an angle, but you still don't have a row that's complete. And you can't use Pythagorean Theorem to get the 3rd side. How come? Yeah, it's not a right triangle. All right, so we're going to see a formula today that is based on the Pythagorean Theorem with kind of an adjustment on the end. So the law of cosines, it almost looks like Pythagorean Theorem, but there's an adjustment for the angle not being 90. All right, so first thing we'll do is we'll go through a proof. It's pretty simple. It's not an overly complicated proof of the law of cosines, okay, which is going to use the Pythagorean Theorem. Okay, so what I'm going to try to do is use the Pythagorean Theorem on this triangle. Okay, I've labeled all the sides and all the angles. I don't think I'm going to end up using all the angles in this problem, but I'm definitely going to use all the sides. All right, so if I wanted to do the Pythagorean Theorem on this red triangle, okay, what's my hypotenuse? C. Okay, so C squared equals, and what's the height of the triangle? How did I label it? Yep, so C squared equals Y squared plus, and this part's a little tricky, but I think we can figure it out. What's the base of that triangle in red?
B minus x.
B minus x. Okay, B is the entire base. X is just the part on the left. So if you take the entire base, subtract the part on the left, you're left with the part on the right. Now, what I want to do is substitute in for x and for y. I want to rewrite x and y in terms of either sines and cosines and this angle, gamma. All right? So let's start with a formula for y. What trig function could you use with gamma that would involve opposite and hypotenuse? Sine. Okay. What would the sine of gamma equal?
Y over A.
Y over A. So then if I got y by itself, what would be the formula for y? Yep, a sine gamma. We're going to substitute that in for y in a minute. Okay, but first I want to get a formula for x. Okay, again, using gamma, what trig function would involve adjacent in hypotenuse? Cosine. So cosine of gamma would equal x over a. So then what would x be? A cosine gamma. All right, so what I'm going to do is fill in that for y, and I'm going to fill in that for x. Okay, any questions on that? And then we're going to do everything else, simplify it, and that's going to give us the law of cosines. So we get c squared equals a sine gamma. Okay, and we're going to square that whole thing, and there's two things inside here to square, the a and the sine gamma, plus b minus a cosine gamma squared. Now, we got to be careful when we square that second part because it's subtracted. Okay, this is like a FOIL or distributive. Okay, it's like trying to square x minus 3. You don't just square the x and square the 3. Okay, so we have to do that all out. All right, so we got c squared equals. What do you get if you square the a and the sine gamma? A squared sine squared gamma. Yep. So a squared sine squared gamma. Plus, now the second part, if it helps, think of it like this. B minus a cosine gamma times b minus a cosine gamma. Okay, so we need to distribute. Yep, so we get b squared. And then we're going to have b times negative a cosine gamma, b times negative a cosine gamma. So 2. Or, yep, 2 of ab cosine gamma. Okay, so we have negative 2 of the a times b cosine gamma. And what about the last part? Negative a cosine gamma times negative a cosine gamma.
A cosine gamma squared.
Plus a squared cosine squared.
Plus a squared cosine squared. Okay, so that's a negative times a negative, so that becomes positive. And then cosine times cosine is cosine squared. Okay, any questions on that? All right, now I'm going to regroup it so that you, bless you, you start to see something. All right, I'm going to write c squared. And let's take this last term, since it has an a squared, and put it next to the first term that has an a squared. Okay, so we're going to have a squared sine squared gamma plus a squared cosine squared gamma. Okay, and for now I'll just leave the rest of it where it is, but I might want to do a little rearranging after. Plus b squared minus 2ab cosine gamma. Okay, now looking at these first two terms, what does a squared sine squared gamma and a squared cosine squared gamma have in common? A squared. So we're going to factor that out. And we're left with sine squared plus cosine squared plus b squared minus 2ab cosine gamma. Now, does anybody see what's going to happen there?
You can factor out b.
So square gamma plus cosine square gamma equals 1.
Yeah, this whole part becomes 1. Sine squared plus cosine squared is just 1 times a squared. Okay? And what's 1 times a squared? a squared. All right, so what we end up with is c squared equals a squared plus b squared. So it almost looks just like the Pythagorean theorem, except for this adjustment on the end, this minus 2ab cosine gamma. Okay, and that's the law of cosines. Okay, but it's one of three ways you can write it. You can write it starting with c squared, b squared, or a squared. It follows the same pattern if you can just look up above. Now, let's see what happens if we tried to use this on a right triangle. Okay, if we use this on a right triangle, what would gamma be? 90. And if I take the cosine of 90, I get 0. And 0 times anything is what? 0. So in a right triangle, this part becomes 0, and you don't need it. If you don't have a 90, cosine of whatever the angle is will not be 0, and then you'll need this last part. All right. Anybody think they know the second way to write law of cosines?
B squared equals B squared minus 2.
What'd you say, Brian? Can you?
I said it'd be B squared equals A squared minus C squared. Minus,
No, question. Where'd you get the minus from?
because when you be, or no, never mind. You, I thought you'd be subtracting from both sides, right? That's different.
Nope, it's going to follow the same pattern, except it's going to be different letters. Adam?
It'd be a squared plus c squared minus 2ac cosine gamma.
Everything's right except gamma. Gamma's has to change.
Beta.
It would be beta. Yeah. So the idea of the law of cosines is it's one side squared equals the sum of the other two minus twice the product of the other two times the cosine of the angle across from the side you start with. Okay, I'm not going to go through and reprove it 3 separate times. Okay, I think doing the proof once shows you where the template for the formula comes from. And then we can just generalize it to starting with either a squared, b squared, or c squared. Okay, so how about the last version?
It would be a squared plus c squared minus 2bc cosine alpha.
Yep, b squared plus c squared minus 2bc cosine alpha. So notice with the law of cosines, every version has every side in it. They all have a, b, and c. All right, so you could probably see where this would be helpful for side, side, side. If you knew A, and you knew B, and you knew C, you could actually use any one of these you wanted. Okay, because you would know everything right up to the cosine. If you knew two sides and an angle, you have to pick the formula that has the angle you know. Because if you know two sides, you're already missing one of the sides. Okay, you can't be missing anything else. So if we had, say, A and B, and we had, actually like this one, we have A, we have B, and we have gamma, we have to use the law of cosines that has gamma. So you'd have to use the first version. Okay? If you tried to use the second version, what's going to happen? You know A and you know B, but you don't know C, and you don't know beta. Okay, you're going to have two things you don't know. Right, so how can you tell that this is law of cosines without sketching the triangle? Just looking at the table. And if you're not sure how you can tell it's law of cosines, how can you tell it's not law of sines?
There's no complete rows.
You don't have a complete row. Okay, that's the easiest way. You don't have a row that's complete, you got to use law of cosines. Okay, and since we know gamma, we have to start with the formula that has gamma, which is c squared. Right, so c squared equals a squared plus b squared minus 2ab cosine gamma. Okay, as we start to go through them, some of these steps I might do in my head, okay, as we go, but for the first one, we'll write it out. Okay, 4 squared gives me how much? 16, 7 squared? 2 times 4? 8 times 7? 6. Cosine 42. All right, what would I do next here? Yep, came in.
You'd add 16 and 49 and take the cosine of 42.
All right, yep, we could add 16 and 49, and that gives me 65. And what did you say to do next, Kanan?
I'll take the cosine of 42.
And we're going to multiply that by
56.
56. In fact, at this point, I could type all that into my calculator. If you want to do this part separate, you can. But let's type it in. All right, so we got 65 minus 56 cosine 42. Okay, make sure you're in degrees. So I get 23.384. And how would I get C? Take the square root of that. So, oops. Second, let's see, square root of my last answer. All right, so 4.836. Right, so let's write that, 4.836. Okay, let's sketch this out and see what kind of triangle we have now. Okay, originally we had A. We didn't have alpha. Okay, we had B. We didn't have beta. But we did have gamma. So this was a side angle side. Now we have C. So was side angle side. What is it now? Yeah, you could look at it as side, side, side. How else could you look at it?
Side, side angle.
Yes, you could look at it as side, side angle. Now these first two would be law of cosines. What would this side, side angle be? It would be law of sines, but what don't we like about this case?
One answer that you got.
It's what?
One of the answers that you got. Oh, no.
You can have one.
Yeah, this is what we call the ambiguous case. It's where you could have the 0, the 1, or the 2 solutions. So if we want to do this as law of sines, we'd have to worry about all that stuff. Okay, so we're not. Yeah, so we're not going to go back to law of sines. Okay, we're going to stick with law of cosines because there is only one answer to this problem. And law of cosines will automatically give us the right answer without worrying about that 2 solution stuff. Okay? Again, you could use law of sines, but you have to be very, very careful to figure out which answer it should be because there is only one. All right, so let's find, let's do alpha. Right? How does my law of cosines start out that has alpha? Yep, a squared. So I got a squared equals b squared plus c squared minus 2 times b times c. 2 times, what was b? 7? Minus 2 times b times c. 4.836. Okay, so that's 67.704 times cosine of, what's my angle here? Alpha. Okay, any questions on that? So a squared, b squared, c squared, 2 times b times c, did that all out, times cosine alpha. All right, now this one's a little different. Okay, this time the variable isn't by itself on one side, so this is more like solving an equation. Okay, and we have to get the variable alone. The other one was more like arithmetic, just adding, subtracting, square rooting. Okay, so when I solve an equation, what would be my first step here? Yeah, let's combine the like terms. So we've got 49 plus 23.384, 72.384. Okay. What would I do next?
Subtract 72.384.
From 16, yes. You cannot combine. A lot of people try to do 72 minus 67. You can't do that. Okay? Think of it as a problem like this. The 67 is multiplied by something you don't know. Okay? It has a variable attached. So the 72 and the 67 are not like terms. Okay? So you cannot subtract them. You have to move the 72 to the other side, and then you're going to divide by the negative 67. Okay? Any question on that? That's a mistake I see a lot. So we'll minus 72,384. Okay, and does anybody have that? 16 minus negative 56.384. Okay. Equals negative 67.704. Okay, what's my next step? Yep, divide both sides by the negative 67,704. And a quick thing to check at this step is your fraction on the left-hand side better be smaller than 1. If it's not, we're going to run into a problem. Okay, so that means the denominator should always be bigger than the numerator. Okay, if it's not, just stop at this point. It's not even worth continuing because you can't take the inverse cosine of something bigger than 1. It won't work. Okay, and law of cosines always gives you a solution. It's not a no solution problem. Right, so now I need, you know what, we could just keep that. 56,384 over 67,704. That's gone. And what's my last step? Inverse cosine. Yep. And now I need to type that in. Okay, I didn't type it in just because it saved me having to round this too many times. Right, so does anybody have the inverse cosine of that?
33.61.
33.610?
612.
33,612.
Let's go ahead and round here.
Right, so 33,612. Okay, anybody else get 33,612? Got something different? And Brian, you typed it in just like that?
Yeah, I typed it in just like that, and then I stored it in the alpha block A and did inverse cosine of the alpha block.
Yeah, I got the same thing as Brian.
Okay.
I didn't, what did you get? Did you guys write?
33.612
I got that
in degrees? Okay. All right, so we'll go with that. Now, at this point, we've got two of the angles. We might as well just add them up, subtract from 180 to get the third angle. If you had extra time, okay, what you could do is do law of cosines again for beta, see what you get. Add the other two, subtract from 180, see what you get. Should be the same. Okay? So you do have a way to check your answer, but it's going to take longer. So we'll add these up. and then subtract from 180. 180 minus 33,612 minus 42. So if I did that right, you should get 104.388. Okay. In this problem, it doesn't matter if you use law of cosines to find beta and then add up and subtract from 180 to get alpha, or the way we did it. Could do it either way. Okay, so with law of cosines, you generally have a few choices on how you do things. Okay, but that's it. That's a side angle side problem. Any questions on that? Okay. So let's look at a side problem. So I said that law of cosines is always going to give you a solution. Okay? And I'm always going to set up the problems so that they do have a solution. But can anybody think how I could give you a side problem and there would be no solution? I've mentioned this a couple of times. Yeah?
If two of the sides, if you added, like say you added A and B and it was smaller than C.
Right. Okay, if I gave you something like sides of 1, 1, and 6, this would be no solution, A, B, and C. Because if you add up the first two sides, they're not bigger than the third. Okay, this would be impossible, and as you went through the law of cosines, at some point you take the inverse cosine of a number bigger than 1. It wouldn't work. Okay, so you're not going to have any like that from me, but that's the only way you could have a law of cosines problem that doesn't work. With side angle side, I don't think it's possible to come up with a problem that wouldn't work. Okay? Yeah, because if you're giving somebody a side, an angle, and a side, you're giving them this. You're not placing any restriction on how long the third side has to be or the angle it has to form between either of the other sides. So I think any side angle side problem would be doable. Yeah, as long as you don't pick an angle bigger than 180, then obviously that would cause a problem. Or negative sides, you can't do that either. All right, so in this one, which version of the law of cosines do I have to use first? It doesn't matter, okay, because we know A, B, and C. So if you look at your law of cosines, you know everything in every formula up to right there. Okay, so basically pick any one you want. We're going to have to do it how many times? At least twice, and then you can add up the 2 and subtract from 180. If you have extra time, you could do it a third time, and then you're finding each answer separate without depending on the other 2. So if you do it that way, it's a little safer, because if you make a mistake, your mistake wouldn't affect anything else. If, let's say, we find gamma and beta, and then we add up and subtract from 180 to get alpha, okay, what could happen there if we make a mistake on beta? Then alpha is definitely going to be wrong. Okay, so that's the safer way to do it, but it does take longer. All right, so as we just said here, you can use any version of the law of cosines. Let's just go through it twice. Do you guys want to find alpha, beta, or gamma? Doesn't matter.
Gamma.
Which one?
Gamma.
Alpha. All right. So who can tell me what to write down to find alpha? A squared. Yeah.
Equals 49
B squared
plus 25
plus C squared.
minus
Let's write this out and we'll calculate it after.
minus 2
2 times 35.
2 times B times C. Yep.
70.
Times cosine alpha. Yep. Okay, so I heard somebody say this earlier. What's 2 times 7 times 5?
70.
Right? And if we add 49 and 25, we get
74.
74. So we do 74 minus 70 and we get 4.
No.
No.
No, Brian.
No, I
No.
was thinking
No, you do.
What do-
Subtract 74 from
Yeah, we got to move the 74 to the other side, and then we're going to divide by the 70. Okay, and I'm already starting to see that the fraction I'm going to get here is definitely going to be less than 1, which is what we want. Okay, what's 81 minus 74? 7. And we're going to have to divide by negative 70. Yep, so you could change it to a decimal or reduce it, but we're just going to type it in and round it off. What do I have to do on both sides? Inverse cosine. All right, so can somebody tell me what the inverse cosine of negative 0.1 or 770 is? 95,739? Okay. Now, you could look at this as a law of sines problem from here. You have enough information. But if you do, it's going to be the side-side angle case. Okay? And then you got to worry about the two no solution stuff. Okay, so to do law of cosines one more time, and then that pretty much finishes up. Okay, you want to find beta or gamma? Beta. Okay. So I'm just going to ask people for these numbers so I don't have to scroll up and down. So what's b? 7. So b squared equals what's a?
9.
So 81 plus 25 minus 2 times 9 times 5.
90.
Yep, 90 times cosine. What are we solving for?
Beta.
Beta. Okay, what's 81 plus 25? 6. Easiest way to do this in your head, 2 times 5 is 10 times 9 is 90. Okay. 90 cosine of beta. Okay, I need 49 minus 106. Negative 57. And we're going to have to divide by negative 90. And, last thing, to get beta by itself, inverse cosine. So the law of cosines, you can really shorten it down. If you do some steps in your head, it's like we only used up 3 lines. If you want to write every step out, it could take 7 or 8 lines. Okay, but do whatever you feel comfortable with for the test. All right, so what's the inverse cosine of 57 over 90?
50.704.
50.704. Now, the nice thing about what we've done so far is we found these answers independently. We didn't use one to find the other. So even if we made a mistake with alpha, beta could still be right. But now I'm going to add these up and subtract from 180 to get gamma.
So 33.557.
33.557. Okay, if you want to check your answer, go through and do law of cosines one more time on the last side. And you can confirm that you're right if you get 33.557. If you get the same answer 2 different ways, then it's probably correct. Okay, any question on the side type? All right. All right, so next thing we're going to look at is how we can find the area of a triangle. Okay, and I've put up the formula that you're probably familiar with already. Area is half the base times the height. And there's 2 formulas we're going to come up with in addition to that. Okay, one of them is based on the law of cosines, and we're not going to go through the whole proof of it. It's pretty long, okay, to go through the whole proof. And the first one here doesn't really connect with law of cosines, but it connects with area of a triangle. So that's why we're doing the formula. All right. What I want to do is look at this triangle and come up with a formula for the height. Okay, kind of like we did in law of cosines using right triangles. if you use alpha, what would be your formula for the height? Think about first, which trig function would you use? Yep, you could use sine. The sine of alpha would equal what?
H over C.
H over C. So what's my formula for the height?
C times sine alpha.
C sine alpha equals the height. Now, I'm going to plug that in for the height. So now the area is going to be 1/2 the base, which I called B, times the height, which is C sine alpha. Okay, so we get the formula 1/2 BC sine alpha. Okay, any questions on that? Anybody have a guess how you can write that, say, from the perspective of beta, if you knew beta? Look at where the two sides are that we used,
Oh,
and look at the angle we used.
sine.
Does it have AC?
1/2 of AC, yep, sine beta, yep. 1/2 of AC, and beta would be right here. And how about if you wanted to write it for gamma? 1/2 AB
Sine.
sine gamma. So rather than memorize all three versions, it's easier just to memorize the concept. The area is half the product of two sides times the sine of the angle between the sides. Okay, so it's half the product of two sides times the sine of the angle between the sides. Okay, and this comes in handy if you don't know the height. Okay, let's say they gave you two sides and the angle. You can find the area using this formula. Okay, and if you have a problem where things aren't labeled, I have no idea if 3 is A, B, or C. I don't know. So I can't pick which version of the formula I'm using. I just have to know the concept. Okay, so what would be my formula to find the area here, just using the general concept?
That'd be 1/2
Yep, 1/2. Yep, 1/2 the product of the two sides times the sine of the angle that's between the sides. And that's it. Now we just do that out. So half the product of the sides times the sine of the angle between them. Okay, what's the product of the sides? And then half of 36? 18 sine 105. 18 sine 105. Yep, 17,387. Anything I should put on that?
Squared.
Yeah, well, square units. Okay, if it was inches, I'd put square inches. I don't know the units. So whatever the units are, it's square units because it's area. All right, so any question on how to find the area of a triangle if they give you two sides and the angle between? Okay, again, doesn't directly relate to law of sines or cosines, but it relates to area. And our next formula comes from the law of cosines. Okay, this is another formula for finding the area of a triangle. The proof is pretty lengthy. It's on page 441, and it takes up almost half the page, so it's not an easy proof to go through. Okay, but it is based on law of cosines. You can check it out if you want to see. And this formula works well if you know all the sides of the triangle. Okay, and the formula for the area is S times S minus every side. S minus A, S minus B, S minus C. Yeah, that's the thing. We don't know what S is. We know A, B, and C are the sides. S is half of A plus B plus C. So what is that? If you kind of summarize, it's half of what? It's half of the perimeter, and we call that the semi-perimeter. Okay, so that's where the S comes from. S is the semi-perimeter. So if you have a problem and the sides are not labeled, it doesn't matter which side is A, B, or C. You have to do S minus every side. It doesn't matter the order you do it in. Okay, and this is called Heron's formula based on the law of cosines. Okay, does everybody have the formula? All right. So I want to find the area of this triangle. Now, if you didn't know Heron's formula, you could do this, right? If you drew it out, especially like on graph paper, then you could draw the height, and you could probably use law of sines or law of cosines to find the height of the triangle. Okay, kind of like when we did the distance the tornado was from the road. Okay, that's like the height. You could figure out the height and then use the old formula. But this is a nice shortcut. All right, let's find the semi-perimeter first. So we got 9 plus 7 plus 5. What's 9 plus 7 plus 5? 21. And half of 21? 10.5. All right, so the area is going to be the square root of what comes first? S. Yep, S minus the first side. S minus the second side. 10.5 minus 5. Okay, eventually we'll need our calculator, but let's simplify a little bit here. What's 10.5 take away 9? 1.5. 3.5. And what's the last one? 5.5. Now, just from the perspective of dimensions, it's kind of weird. You're taking a length times a length times a length times a length. So if you did that, what's like inches times inches times inches times inches?
Inches to the fourth.
It's inches to the fourth, but then when you take the square root, it becomes inches squared. Okay, so that's why this works dimensionally. Okay, you have inches to the fourth, but then you take the square root, inches squared. All right, so now we need to just type that in. So we get square root of 10 point, what were the other numbers? 10.5, 1.5, 2.5, 5.5. Okay, so we get about 17.412. Anybody else get that? So a nice simple formula as an application of law of cosines. Again, not going through the proof, but to find the area of a triangle. Okay, any questions on that? All right. Yeah. Okay, so let's finish up with this one. Okay, so this says a surveyor wants to find the distance between 2 points A and B on opposite sides of the building. The surveyor locates a point C, so that's where they're standing. And that point is 110 feet from A and 160 feet from B. Find the distance between these 2 points. Okay, so anytime we have a word problem, what do you think best thing to really do first is? Yep, make a picture. Right, so I've already set up my picture. Okay, points A and B are on the opposite sides of a building. Now, you could imagine maybe this is like a canyon. Okay, so if there wasn't a building here, maybe they want to measure the distance across a canyon, and they really can't do it. In this case, with a house, you probably could measure, up to the house, then measure the front of the house, and then continue measuring. But if there was a river or something, that would be a little harder. Right? And it says that point C is 110 feet from point A and 160 feet from point B. Okay, the other piece of information they give us in the diagram that they didn't give us in the description, at least I don't see it, is the angle formed at ACB. Okay? If you didn't know angle ACB, you couldn't do it. Okay, so we're going to find the distance between points A and B. Okay, what kind of triangle is that? Classifying it with the 3 letters, S's and A's. It's SAS. And side angle side falls under which law? This is law of cosines. All right, so now here's where we just have to understand, I think, the general idea. One side squared equals the sum of the other 2. Okay, so start with that. Okay, let's call this side x. One side squared equals the sum of the other 2. Minus what comes next. Yep, minus 2 minus twice the product of the other 2 sides times what? Cosine of the angle between the sides. Cosine 54. Okay, this one is more of an arithmetic than an algebra problem because the variable is already by itself. We're just going to end up multiplying, adding, and then taking a square root. Alright, so let's do this out. So 110 squared is 12,100 plus 160 squared, 25,600 minus 2 times 110, that's 220 times 160. Okay, 35,200. Cosine 54. 54. All right, what do I do next?
Combine like terms.
Yep, combine like terms. Okay. What's 12.1 plus 25.6? So 37.7 minus 35.2. Now you could have done something extra in that step, but we're kind of breaking it out here. What's my next step?
Cosine 54.
Yep, so we're going to take 35.2 and then cosine 54, multiply them together. 35.2, oops. Cosine, what was it, 54? Okay, we get 20,690.04. Okay, next step, we're going to subtract these and then take the square root. Okay, let's just type it all in at once. Square root 37.7 minus 20,000. Actually, I could have just done minus second answer because it's the last thing I had. 690.04. Okay, so we should get a distance between the houses of 130.42 feet. Yep. So, it's like this. Okay, now what if I said to you I wanted the answer in feet and inches, like 130 feet and how many inches? How would you do that? What would you multiply by 12? Just the 0.42 part, okay? So we have 130 feet, and then we have 0.42 feet left over.
That's 5 feet.
So that's 130 feet, 5 inches, and a little bit more. Okay, it's a little over 130 feet, 5 inches. Most of the time when people are measuring, I don't think they measure 130.4 feet. They probably would measure either to like the 16th of an inch, or that's probably not a common number in like carpentry or something. So you could convert it if you needed to. Okay. Any questions on that? All right, so we looked at law of cosines, went through the proof. So now we should be able to solve side angle side, side side side. Should be able to find area of a triangle, either using 2 sides and an angle or all 3 sides. And be able to do a word problem where you have to make your own diagram involving law of cosines. All right, so the homework is on 443. Okay, I'd like you to try 1, 2, 5, 6, 13, 14, and 17 through 20. Right, so tomorrow we'll look at sections 8.3 and 8.4, which totally different. We're done now solving triangles. And we'll have our test on Friday.